name is Becky and I'm an engineer at RadTech. I've done a few experiments with you guys before, but today we're going to do one I'm really excited about. And we're going to take some household goods and make plastic out of it. So, plastic is something that we use in our everyday lives. If you look around your room, I bet you can find at least 5 things that are made of some type of plastic. But there are different types of plastic. So what we're going to do today is make a type called casein plastic. And I'll walk you through why this is created through using these household products and what we're doing with the chemistry. But quick, just a fun fact about casein plastic. It's actually one of the older forms of plastic. They used this a lot in the early 1900s before they had large manufacturing techniques and used other types of plastic. So this could be made from household items and was used to manufacture things like buttons. It's not very widely used today just because we have better types of plastic that are quicker to make and easier, but this one's easy to do at home. And personally, I'm going to make an ornament out of it, but you can make whatever you want out of it. And we'll make about this much plastic. So if you're going to make something small, this is what you want to do. So we're going to start with our ingredients, which are milk. You can use any type of milk for this, but I would recommend low fat if you have it. And then we're going to use some white vinegar. So I just have distilled white vinegar. I haven't tried this with other types of vinegar, but if you're interested after and you want to do it again, maybe you can try it with other types. And then we're going to need a teaspoon, a cup measure, a spoon, some paper towels, a plate or something that you don't mind getting damp, and then we're also going to need a microwavable mug. So one thing about this experiment is that we are going to use the microwave for it. If you have a parent or an adult nearby who wants to help out, you can do this on a stovetop, but I'm going to do it in the microwave. So we're going to start by taking a cup of milk, and then we're actually going to heat that milk up in the microwave. So while we're doing that, we're going to talk a bit about the science behind this experiment. So I've got my cup of milk right here, which I have to be careful not to spill. And then I'm just going to go ahead and pour that in my microwave safe mug. Before you do this, please make sure that whatever mug or bowl you're using is actually microwave safe. We don't want to damage your house or your microwave. So you've got our mug full of milk. And I'm going to go put this in the microwave for about a minute at a time, and we want to get to the point where it's about where you would want to drink hot chocolate out of it. So warm and steaming, but we don't want this to be boiling. So while our milk's heating up, we're going to take a second to talk about the science. We've talked about molecules a bit previously, but we're going to do a brief review of those and then talk about exactly what's going on in our experiment. So everything around us is made up of molecules, and molecules are the smallest building blocks of life, which are called atoms, that bond together with other types of atoms. So they form sort of a group. And once you have these molecules, those can link up with each other and form another sort of substance. So this milk jug that I've got is filled with molecules that are linked together in certain patterns, and that's how they determine what material that they're going to be. Whereas the milk inside it is a little different. So the milk inside of it is made up of monomers, which is just one molecule. They're not linked together really. So what we're going to do is we're going to cause those singular molecules, which are just standing there all alone, to link up with the rest of them in the milk. And then we're going to tangle those up, and that's what creates our plastic. So plastic is made of what's called polymers. And polymers are long chains of molecules strung together. So imagine it as a piece of yarn. And then what we do to make our plastic is we take that piece of yarn and we just kind of bundle it up like this and wrap it up and make it become this confused bundle of yarn that can't be pulled apart. So when we introduce our vinegar, it's essentially taking those monomers, stringing them together, and then we're going to bundle them all up to make one cohesive ball of plastic. Alright, so I've got my nice hot steaming mug here of milk, and I don't know if you can see it, but there's actively a lot of steam coming off of it. Just a reminder, don't touch your mug if it's super hot. I ended up setting mine for about 2.5 minutes in the microwave. So I'm going to take it and I'm going to put it into this glass mug just so that you guys can see the sides of the mug while I'm working. So we're going to be super careful here. All right, so we've got our still steaming hot mug of milk. And then now I'm going to go ahead and put 4 teaspoons of vinegar into this. So we've got 1, 2, 3. That's my cat Saffron. Apparently she wants to join in the experiment. And then we're going to add a 4th. So if you can see, the surface of the milk looks kind of gross already. So what's happening right now is the milk is separating. So we can go ahead and stir it a little bit. And if you see my spoon, there's some gross milk chunks on there. So those are called curds. And those are what we're going to use to make our plastic in the end. So it's separating even further. And you can see the curds really forming here. All right, and they're kind of sticking to my spoon. So once you've got some curds nice and formed, like, look at that, then we can start taking them out with a spoon. And we're going to put them on our plate with our paper towels. So take our nice gross curds. We're just going to plop them on the plate with our paper towels. And this is why you need a surface you don't mind getting damp, because you are going to have some of the water coming out of the milk and the vinegar. And now both my cats will play. Okay. So take a minute and try and get as many of the curds out as you can. That's going to be really important for how much plastic you can make. And try not to get it on anything else. If you do get it on something else, be really careful if you're picking it up with your hands. The milk was just very hot, so your curds are probably still going to be hot too. And I'm trying my best to get all the water out of the curds before I put them on the paper towel, but it is kind of hard. So those are my curds. So this is what's rearranged itself in the milk. You've got all these monomers that are now linked up because of the vinegar we added. And now they've formed these long chains of polymers. And so as you're scooping up your milk or your substance like this, you're actually scooping up pieces of those polymers that are tangled together, and that's what this plastic is. Also be careful if you're touching your spoon, because that's probably hot too. So now we've got this interesting pile of plastic, and I'm just going to go ahead and pat this dry, and be careful, it's still really hot. So I'm trying to get as much water out of it as possible so it dries as soon as it can. And then be careful because mine's still a bit hot. If it's cool enough to touch, you can start shaping it. If you have a cookie cutter, a small one, this is a good time to play with it. Or what you can do is you can try and dye it. So if you have food coloring, you can go ahead and add that to the plastic. It actually takes to dye really well. Or you can add glitter. I wouldn't add sprinkles or anything like that because that'll be a lot harder to mix in. But you can take this time to kind of play with your plastic and see how it pulls apart. So it's not like Silly Putty, where you can pull it and it'll just keep stretching. This breaks a lot more easily, but you can squeeze it and try and get the rest of the water out, and then you can kind of shape it. So since I don't have a cookie cutter, what I'm going to do is use a butter knife, and I'm just going to cut mine into a couple shapes once I finish squishing it. So it doesn't have a super flat texture like other plastic will, but that's based on the manufacturing technique. So if we're doing something with our hands like this, it's a lot harder to get a perfect flat surface than it would be if you're using some sort of mold, or like if you were to flatten it against this metal surface that's already flat, it would take a lot better. So this is my triangle that I'm going to use, and it kind of looks a bit like a really gross chip, but I'm going to leave this to dry. So when you leave this to dry, it will take a while. I'm going to try leaving mine for 2 hours, and then I'll come back and see how it goes. So the other thing is, I'm also going to put this on a drying rack that I use for cookies, and that way it'll hopefully hold flat and also get lots of air around it to help it dry, so it's not stuck in like a cold, wet environment. And once it dries, I'm going to make it into an ornament. You can also paint this once it dries and color it with markers, which is super cool. So if you want to make an ornament for your parents, this is a good way to do it. So this is the final result for my ornament, and this has been left to dry for a few hours, and it can actually still kind of squish a little bit. So if you want to get this to fully dry to the point where you can paint it and whatnot, you should wait about a day and then see if it's tough when you squish it. Also, if you roll yours out or shape it to be a bit thinner, it'll dry faster, which means you can paint it sooner. So thank you guys for joining me in this experiment. And just to recap what we learned, we talked about how we can turn molecules, which are the building blocks of everything around us, into long chains of molecules and really tangle those up so they become some sort of plastic, which was very commonly used back in the 1900s, and we can still make by ourselves today. So I hope you guys really enjoyed this experiment. I think it's fascinating, and I hope you have a great rest of your day. Thank you.